You know how everyone's always talking about the speed of tech innovation? Constantly accelerating.
Yeah, it's pretty much nonstop.
We'll get this. There's a company, Cursor AI, that's gone from basically zero to an incredible $500 million in annual recurring revenue. And they did it in less than 2 years, just 21 months.
Wow. 500 million ARR.
500 million. That's faster than Slack, Zoom, or Shopify even managed to hit the 100 million ARR mark. I mean, it's completely record-breaking speed in the SaaS world.
That's astonishing.
And here's the really surprising part, the twist. The secret weapon behind their AI coding assistant isn't just some brand new, super advanced AI model. Well, that's part of it, but the core. It's built on a computer science concept from, believe it or not, 1979.
1979, really?
Yeah, something that also powers stuff you probably use all the time, like Bitcoin, Git for version control, Bittorrent. That's where this story gets really interesting.
Okay, yeah, that is interesting because it's not just another AI does something cool story. This sounds more like smart engineering, like leveraging fundamental principles to solve a really tricky problem developers face.
Exactly right. It's that fusion of old foundational ideas and cutting-edge AI that makes their growth so, well, unique and significant.
So what is Cursor AI then? Just another editor?
Well, on the surface, yeah, it looks like a code editor. But today, our deep dive is into how, underneath, it's tackling one of the biggest headaches in AI-assisted coding.
Which is?
How do you get an AI to actually understand your entire code base, all the context, all the nuances, without, throwing user privacy out the window or making the tool painfully slow?
The context problem. Yeah, every developer knows that one.
Totally. You use an AI helper and it just feels like it's guessing in the dark, right? It throws out generic code snippets that don't match your project style or your naming rules or just the way things are actually built.
Mm-hmm. Like it hasn't actually read the rest of your code.
Exactly. It's like, say you're working on a complex React app, you've got custom hooks, a unique setup, and the AI suggests something completely vanilla, totally out of sync. It's like asking for help fixing your custom race car and getting handed a wrench for a kid's bike. It just doesn't fit.
Right. And modern code bases are enormous.
Oh, the scale is immense. You're talking thousands of files, sometimes millions of lines of code, tangled dependencies, unique architectural patterns. How can any AI possibly grasp all of that deeply, accurately, and instantly?
And it's not just a technical puzzle, is it? There were some huge hurdles here.
Like what?
Well, first off, privacy, big one. Developers, companies, they're just not going to upload their secret sauce, their proprietary code wholesale to some third-party AI. That's a complete non-starter for most.
Absolute security nightmare.
And then performance.
Yeah.
Imagine uploading gigabytes of code every time you wanted the AI to help. It would just grind to a halt. Unusable.
Yeah, no kidding.
So the big question for any tool trying to do this was, how do you get that deep context across the whole project without killing speed or compromising security?
That's the billion-dollar question, right? Especially when you think developer salaries are, what, 150K plus on average? Even a small productivity boost from a tool like this is a huge value.
Massive potential.
So Cursor's aha moment, their big insight, was realizing they needed all three. Total codebase understanding, ironclad privacy, and lightning speed all at once. And chasing that kind of ambitious goal led them back to this surprisingly elegant idea from 1979.
Okay, I'm hooked. Let's hear about 1979.
Right. So back in 1979, there was this computer scientist, Ralph Merkle. He invented something called a Merkle Tree. Now, I'm pretty sure he had zero clue back then that his invention would end up underpinning cryptocurrencies, Git, and, the fastest growing AI company ever.
Probably not. So what is a Merkle tree in simple terms?
Okay, think of it like this. Imagine you have a big stack of important files. Instead of checking every single file every time to see if anything changed, you could give each file a unique digital fingerprint.
A hash.
Right, a hash, like a checksum, but more robust.
Exactly. Then the Merkle tree builds a kind of hierarchy, like a family tree for those fingerprints. You group file hashes together, calculate a combined hash for that group, then you group the groups, hash those, and keep going up.
Until you get one single hash at the very top.
Precisely. One master fingerprint for the entire stack of data. That top one is called the root hash.
Okay, hashes. Just to be clear for everyone, these are unique digital fingerprints, right? You run your data like a code file through a hashing algorithm, and you get this small string of characters that represents it.
Yeah, a unique signature.
And the really clever bit, the thing that makes them so powerful, is their sensitivity. change just one character in the original file, and boom, the hash changes completely. It's incredibly precise for detecting changes.
So you know instantly if something's different. And here's the Merkle Tree magic. If any file, any piece of data changes anywhere down in that stack, the change ripples upwards. The hash of his group changes. The hash of that group's group changes. All the way to the top. The root hash changes.
Ah, I see.
So you can tell if anything at all in that huge data set has been altered just by comparing one single small number, that root hash. You don't need to rescan everything or resend all the data. Just compare the fingerprints.
Okay, that makes sense why it's used elsewhere then, that instant verification.
Exactly. Bitcoin uses it to verify massive numbers of transactions super efficiently. Git uses it under the hood to track every change you make to your code, ensuring integrity between versions. BitTorrent uses it to check file pieces are correct as you download them.
Right. Okay, so Cursor's founders looked at this and thought,
They had this brilliant realization. A software code base is basically just another distributed system. Think about it. Your local files are constantly changing. You need to sync things with remote systems, maybe your teammates, or in this case, an AI server. And you want to transfer the minimum amount of data needed to do that sync.
it's the same core problem Git solves, or Bitcoin just applied to feeding context to an AI.
Exactly. That was the breakthrough. They realized Merkle trees could create this compact, efficient fingerprint of the entire project. And then, crucially, use that fingerprint to figure out only the specific bits that had actually changed since the last check.
Instead of uploading the whole thing every time.
Precisely. So you get the full context to the AI, but without the massive data transfer or exposing all your code constantly. It neatly sidesteps those big privacy and performance issues we talked about.
Yeah.
It's really smart engineering.
Okay, let's dig into how they actually implement this. You said it's a 5-step process. Sounds elegant.
It really is quite clever.
So what's step 1?
Step 1 is intelligent code chunking. And the key word here is intelligent. Cursor doesn't just chop files up randomly. It uses something called abstract syntax trees, ASTs. Think of an AST as like a detailed map of your code structure. It knows what's a function, what's a class, what's a variable declaration.
So it understands the meaning, not just the text.
Exactly. And uses this understanding to break the code down at logical boundaries, like a whole function or a class definition. So if you just change one function, Cursor knows exactly which specific chunk was affected. It doesn't need to reanalyze the whole file.
Okay, that makes sense. Chunking smartly. Then what? Step 2.
Step 2 is Merkle tree construction. And this is crucial. It happens entirely on your local machine.
Ah, so the code isn't sent anywhere yet.
Not yet. When you tell Cursor to index your project, it scans everything locally, calculates the hashes for all those chunks we just talked about, and builds the Merkle tree right there on your computer. Your actual source code never leaves your machine during this step. Only the fingerprints are calculated.
That seems absolutely fundamental for privacy and speed, keeping those first 2 steps local.
It's huge. It directly tackles those core problems. By hashing locally, the main privacy worry sending raw proprietary code is immediately reduced. And performance-wise, calculating hashes locally is super fast. You're not bottlenecked by uploading massive files just to get started. It's privacy by design, really.
Right. Okay. Makes sense. So hash is computed locally. Then step 3.
Step 3, server synchronization. Now, Cursor sends that Merkle tree structure, basically the map of hashes, along with the actual code chunks themselves, up to their servers.
Okay, so the code does go up eventually, but in chunks.
Yes, but importantly, for extra privacy, the file paths associated with those chunks are obfuscated first. So the server doesn't know it came from users your project's supersecretfile.js.
Got it. Anonymized chunks. What happens on the server? Step 4.
Step 4 is AI embedding creation. On Cursor servers, each of those code chunks gets processed by an AI embedding model. This could be OpenAI's or maybe Cursor's own custom one.
And embeddings are, like AI understanding the meaning.
Kind of, yeah. They create these vector representations, basically lists of numbers that capture the semantic meaning of the code chunk. What it does, its purpose, how it relates to other code. This lets the AI truly understand the code beyond just keywords.
And where do these embeddings go?
They get stored in a specialized database called a vector database. Cursor uses one called TurboPuffer, which is optimized for finding similar vectors really quickly. And here's another key privacy detail.
Yes.
They index these embeddings using the hash of the code chunk, not the original file path or name.
Ah, okay. So even the storage index is anonymized. What's the benefit of that in using a vector database?
Well, indexing by hash adds another layer of privacy. Even if someone saw the database index, they couldn't easily tie an embedding back to a specific file in your project. And the vector database, like TurboPuffer, is like a super efficient library for the AI. It lets the AI instantly find code chunks that are semantically similar to what you're working on or what you're asking about. It's searching for meaning, not just text matches, which makes the retrieval way faster and much more relevant for providing good suggestions.
Cool. Okay, so chunks are on the server, turned into embeddings, indexed by hash. What's the final step?
Step 5.
Step 5 is where the real magic happens. Incremental updates. This is what keeps the AI constantly in sync with you.
How does that work?
Roughly every 10 minutes, or when it detects a change, Cursor quickly recalculates the Merkle Tree hashes for your local files, just the hashes, super fast. Then it compares the new root hash with the root hash version stored on the server.
And if they don't match? If the root hashes don't match, Cursor knows something changed. And because of the Merkle tree structure, it can instantly pinpoint exactly which branches of the tree have different hashes, and therefore exactly which specific code chunks were modified.
Without rescanning everything.
Exactly. And then, this is the kicker, it uploads only those tiny changed chunks. So if you just tweak one function or fix a typo in a comment in a massive project, only that tiny little chunk gets resynced. The AI's understanding is updated almost instantly.
Wow. Okay, that is clever.
So put it all together, what does it mean for the developer using it?
Well, it sounds like you get an AI that actually understands the whole context of your specific project.
Yeah.
It updates almost immediately when you change things.
Here instantly.
It protects your privacy because you're not constantly uploading everything and paths are hidden.
Right. Minimize data transfer, obfuscation.
And it should scale to pretty much any size code base, right? Because it only deals with the changes.
Exactly. Small projects, huge enterprise monorepos, doesn't matter. This technical foundation, combining Merkle trees with smart chunking and embeddings, is what enabled Cursor's, well, unprecedented growth.
And those growth numbers are just wild. I mean, seriously, $1 million ARR to $100 million ARR in 1 year.
12 months. It's insane.
Slack took 2 years for that $100 milestone. Zoom took 3, Shopify 4. Cursor did it in 1. And then hitting $500 million ARR by May 2025, that leads to this projected $9.9 billion valuation. And the team size, just 60 people.
60 people for that level of revenue is incredibly lean. Speaks volumes about the product's traction.
Totally. Over 1 million users now, 360,000 paying customers, adding thousands of new developers every single day. It's not just fast growth, it feels like a fundamental shift.
And you can trace that adoption curve right back to the tech we just discussed.
Yeah, developers aren't just saying, oh, it's neat. They're saying things like, it feels like coding with a helpful AI pair programmer. Why? Because the suggestions actually fit. They match the existing architecture, the team's patterns, the naming conventions.
That deep context makes all the difference.
It transforms the AI from just, a fancy autocomplete into something that feels like a real collaborator. That's the key differentiator driving this viral adoption.
And it creates this huge competitive advantage, right?
Huh.
While others might offer generic AI help, Cursor offers personalized AI. It knows your code, your style.
Like it's been trained just for your project.
Exactly. And that level of understanding is gold. It's why whole engineering teams adopted it, why enterprises signed up. They could see measurable productivity gains. Plus, you get that network effect. More users mean more interaction data, which helps refine the models, making it even better. It's a virtuous cycle.
But of course, success like this attracts attention. Big attention. Cursor's now in this head-to-head battle with the giant in the room, Microsoft's GitHub Copilot.
Yeah, the incumbent. And Copilot has some serious advantages.
Oh, yeah. Deep integration with VS Code, 70% plus of developers use VS Code, plus all of Microsoft's resources, their data, their cloud power. GitHub Copilot itself is already a huge business, pulling in over $300 million a year.
It's a proper David versus Goliath fight.
So how is Cursor, this smaller company, actually competing? How are they holding their own?
Well, fundamentally, by just being better at that core, hard problem. Understanding the whole code base context.
You mean it actually works better day to day?
Seems like it. There are independent benchmarks suggesting Cursor's around 22% faster for certain coding tasks. And maybe more importantly, developers consistently report that Cursor's suggestions feel more relevant, more contextually appropriate.
So it's not just faster, it's smarter in context.
That seems to be the consensus. It translates into less time fighting the AI and more time actually coding productively. Saves time, improves code quality. Developers notice that.
And technically the difference is, Copilots may be better at single lines, while Cursor handles bigger picture stuff.
That's a fair summary. Copilot is excellent at that immediate line-by-line suggestion, the autocomplete plus 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 bed. Cursor really seems to shine when you need help with more complex things, refactoring code across multiple files, understanding architectural implications, dealing with the structure of the whole project.
And Cursor offers more choice in the underlying AI models too, right?
Yeah, that's another point. You could pick between GPT-4, Claude 3.5, Sonnet, Gemini. Gives users flexibility. Copilot is more tightly integrated with OpenAI models, so if you prefer Claude's style for certain tasks, Cursor lets you use it.
Interesting. And the competition's heating up in other ways too.
Oh yeah, it's become a talent war as well. Cursor recently hired some key engineers from Anthropic, folks who worked on Claude Code.
Yeah.
That's a big signal they're serious about pushing the boundaries of AI specifically for developers.
So the big strategic question then is, can a standalone focused tool like Cursor truly compete long-term against Microsoft's integrated ecosystem, especially with big companies that already have huge Microsoft deals?
That's the billion-dollar question, isn't it? It's fascinating to watch play out. Does the best-in-class tool win, or does the deeply integrated ecosystem player dominate?
Yeah. And this whole Cursor story, it feels like it points to something bigger, doesn't it? Like a fundamental shift in how software gets made.
Absolutely. We're moving beyond traditional IDEs, integrated development environments that maybe just tacked on AI features later. AI native tools like Cursor are rethinking the whole developer workflow with AI baked in from the start.
Right. Not an add-on, but the core.
And you hear predictions, right? That in, say, 5 years, a lot of coding might happen more in natural language or pseudocode, with the AI doing the heavy lifting of translation.
But we're not quite there yet.
Not fully. Today's AI is amazing for certain tasks, generating functions, boilerplate code, but they still struggle with really complex architectural decisions, debugging gnarly distributed systems, or truly grasping the subtle business needs behind the code. That deep context Cursor provides is still vital.
So what Cursor really proves, bottom line, is that context is king.
Absolutely. The AI that truly gets your whole project, your team's quirks, your architectural choices, that's the AI that's going to win. It's not just about spitting out code fast. It's about intelligent, context-aware partnership.
And looking even further ahead, what's coming next?
Well, people are talking about truly autonomous coding agents maybe emerging late 2025. AI models with vastly larger context windows like 10 million tokens or more. AI assistants that understand not just the code, but the entire business domain, the user requirements.
Wow, that could really change things, make software development accessible to way more people.
Potentially, yeah, democratize it in some ways. Which, of course, brings up that important question for all of us.
As AI gets better and better at the actual writing of code,
How do junior developers learn the craft? How do we make sure we still have that pipeline of deep human expertise and innovation? It's something we need to think about.
it's definitely food for thought. So, if this deep dive resonated with you listening, maybe share it with developers or tech folks you know. Get their take. Ask them about their experiences with AI coding tools. What do you think about Cursor's approach?
Yeah, and stepping back, the Cursor story is just such a powerful reminder, isn't it, about the lasting value of foundational computer science. Ralph Merkle, back in '79, he probably never dreamed his abstract idea would be key to building the fastest-growing software company ever, decades later.
That really is the beauty of great CS concepts, right? Elegant solutions just keep finding new revolutionary uses. So in this crazy race between AI coding assistants, maybe the winner isn't just the one with the fanciest AI. Maybe it's the one with the smartest engineering built on those solid foundations.